More robots. Woo! All right, hello, Russell.
That'd be cool.
Yeah, it would be totally cool. Wow, look at this webcam, eh? It's like totally retro pixels. Um, ooh, paper. Russell, if you're talking right now, your microphone may be muted. Is he here?
There we go. I don't know how it got muted.
Oh, okay. Cool.
Can you hear me?
Yep.
Working now. So how come my mic is not working?
It's
working now?
It's working now, yes.
Okay. Okay. So what you're looking at here is a recycled HP, I think HP printer. And I've got the, let me see, can you guys see? Let's just try holding it over here. You can see if I hold it. Come on, refresh. There we go. It's great. See the wheel?
Yep.
Everybody sees the wheel? Yeah. Okay, the wheel is an opto encoder.
Cool.
So there's two opto detectors on that wheel, and they can detect which direction it's going in. Most people should be familiar with that, right?
Yeah.
Yes.
Yeah.
Yeah. So I have one of the opto encoders is connected to an interrupt pin, and the other one is connected to an input pin. So in the interrupt service routine, I look at the input pin. So every time I get a click on the one opto detector, I look at the other opto detector to see which direction it's moving. Now, this is all Arduino code.
Yeah.
And it can handle that. It can handle all of those ticks, however many ticks per second that ends up being. So it knows where the paper is in the printer. Yep. Now, can you hear?
Sounds like a motor.
Can you hear the printer singing?
Yep.
Yes. Okay. So what that is the PID algorithm attempting to seek to the location. The problem is I don't have it tuned properly. Now, if I move this by hand so that it gets... Can I even get it there? No, I can't get it there. It's so badly tuned. It's so badly tuned that I can't get it there by hand. But it's trying. It's doing its best to get there even with my bad tuning. So what I'm doing is using the PID algorithm. And that stands for proportional, integral, and derivative. So you've got the optodetector here that tells you the position of the motor. And then you've got the motor driver. Can you see the motor shield? This is a regular old Arduino motor shield.
Nice.
So that's driving the motor. So I've got the position, and I've got the motor speed controlled. The PID algorithm connects the two. So with the PID algorithm, you take a target position, and you take the current position. And that algorithm compares the two and applies proportional,
Gesundheit, Robotassen. Gesundheit, Robotassen.
Thank you. Well, I ate peanuts earlier. This is one of the stuff. Anyway, so the P, I, and D are three parameters for this algorithm, and they're small signed integers. And the idea is...
Wait, what?
What?
Integers? How?
Yeah. Proportional, integral, and derivative. That...
No, but how do you...
Is the...
Sorry. How do you tune it with integers?
You use really big integers and then you divide them.
Oh, okay.
To get the fractional bits out. So what the algorithm does is it takes the difference between the target and the current location, that's your error, and it integrates that by adding it up, and it takes the derivative of it by taking the delta from this position and the previous position on the previous go-round, and it takes the proportional difference, which is just the error itself, and it multiplies all three of those times a factor, which you set, that's the tuning, and then it throws that at the motor. So you're calculating from 3 inputs. Well, you're calculating from 1 input, 3 different values calculated over time, and you throw it at the motor. And if you get it right, then you tell the motor, go here. And it goes, and it stops on a dime at your position. Unfortunately, I don't have it tuned right. So I can't show you anything other than the paper moving back and forth. See, I can do this by hand. I can move it by hand, and then it oscillates a little bit, trying to seek to the right location. But when you get it, it is such a great algorithm for controlling motors when you get it tuned. And anybody you talk to about PID says, yeah, tuning's the hard part. Writing the algorithm, easy.
Easy, yeah.
Easy, yeah. So that's my sort of attempt at a robot and my PID algorithm.
Thanks for explaining PID. It's always fun to hear PID explanations from different people and different demos.
Yeah, I'm sure. Okay, next person?
Yeah, I think... Wow, thanks for showing that, by the way. Okay, I'll just mute you because your mic... Yeah, alright, thanks again. Okay, so... Let's see. It is 9:33, and I do have a tutorial, but I also have these circuit programs to learn, so I think I'll save the tutorial for next time. But I'd just like to thank everyone again for coming to the robot party. Wow, it was amazing. We learned so much stuff today and saw so many amazing projects. So thank you, everyone. I don't know if we'll be here next week because I don't know the number of next week's day. But if it's reasonable, we will be here. And
it's the 22nd.
22nd, that's reasonable, so we'll be here. And then you can learn about the tutorial of acceleration with my robot. I'm looking at my robot right now. Ooh, switching cameras. It's using again this robot, but instead of braking, it's accelerating. Alright. Thanks everyone again for downloading all this information into everyone's brain. Fantastic. See you next week.
Have a good night.
Bye-bye.
Holy cow, what an awesome robot party. Yeah! Alright, thanks everyone on the stream for tuning in. I hope you enjoyed it. Hope you learned a lot of stuff and got lots of information downloaded into your brain. So much robots, so much time. Let's build robots. Tune in next week for more robots.